Yes, hello everyone. Um, uh, I'm Vladimir Polushin, and we're going to talk about Scalafix and how to enforce best practice with it. So a little info about me. So I have participated twice in the Google Summer of Code program in the Scala organization, and also have contributions to the FastParse, Enzyme, Scalafix, and Scalafix apps. Okay, now to the talk. We are going to talk about the abilities of Scalafix, first of all, about linting, rewriting, built-in rules, and a few words about word remover. It's another linting tool for Scala. And we will talk about limitations of Scalafix and the future plans or how to overcome this limitation in the future. Okay, so what is the Scalafix? It's the main part of the Scalafix is a static code analysis. So we can match on some specific constructions in our code. And then we have two ways. First way is to detect the bad code and throw an nasty arrow saying, yeah, it's really bad and you should never use it, and I won't let you to run this project never again. And it's called linting. And the second way is to replace the bad code with a good one, and it's called rewriting. And rewriting also can support porting Scala code to Dotty. Actually, that was the main purpose of the Scalafix initially. Okay, so how to write the actual code, how to use linting and rewriting in the Scalafix. Every analysis of the code in Scalafix should be in the rule. Rule is a separate class with the main fix method. So we have here a class, some desired rule. We should extend from the general rule class and pass the name of our rule. And here we have fix method that takes the rule stakes, rule context, and returns the patch. So rule stakes contains some information about the code. For example, raw code string, list of tokens, AST, and other things. Also, it has methods to work with structures and the semantics. Well, it's about semantics, semantic DB. We will talk about it later. So we have rewriting and linting. If we're looking at the writing, everything is quite simple. We take the rule context, doing some things, replace code, and return the patch to our code. But with linting, it's another situation. We return a sequence of errors, lint messages. And lint messages, of course, can't change, replace code, but we should convert them to the patch. Well, it's of course the messages won't change the code. It's only for the interface unification. So rule always returns patch. And it's time to write your own rule. But first, we should consider a problem. Well, that problem, something we want to block. So implicit conversions. Well, I hope you all know what implicit conversions are, but from the syntactical point of view, it's an implicit function that has at least one non-implicit parameter. Here we have implicit conversion to convert integer to double. Well, implicit conversions can produce often a lot of errors, undefined behavior, and etc. So we would like to block it. We will need to use the syntactical information. And Scalafix uses Scala meta for the syntactical information or for AST construction. So we can access to this AST by ctx.tree, and the tree has a collect method that takes the partial function and collects the result from that function. So we would like to block the implicit function, so we have to look at the node in the AST, a node of function definition. It's called def and def in Scala meta, and well, here's the scheme of that node. It consists of modificators, name of the function, type parameters, list of parameters, regular parameters, optional type for that function, and the body of function. We need only function modifiers and parameters. And putting all together, we have tree collect method, and we match only on def and def and retrieve mods and parameters. And we check that mods indeed contains implicit modifier, and parameters contains at least one parameter that doesn't have the implicit modifier. And then we throw an error. I won't show how to throw errors, how to write that code, because it's quite boring, quite monotonic, and actually it's quite simple. So you better to look at the actual code base and just copy paste that boilerplate. But yeah, that was too easy. We use only syntactical information and don't use semantic information in our example. So let's move to another example. It's rule called missing final. So consider the following situation. We have sealed trait in one file and another trait that extends from trait A that extends from that sealed trait. And we can extend from that trait A is in another file. So we have trait B that inherits from the sealed trait, but in another file, in file 2, and it looks quite bad. So we are blocking it. Well, again, we will look at the node of trait definition, def and trait in Scala meta. It again contains modifiers, a name of the trait, type parameters, constructor, and template. Template stores information about parents, initialization, and the body of the trait. Well, don't be afraid of constructor in the trait, because Dirty allows to have constructor in the traits. Well, okay, and we will need only the parents, so it's template.init. And while having the parents, we actually can't determine whether the parent is sealed, only with information from AST. There will be only a name of that parent in the AST. So we will need to use semantic information. And for semantic information, Scalafix uses semantic DB. Basically, Scalafix builds for every Scala file some index for semantic DB that stores some connection between inner types, exported symbols, imported. Well, there have been all of presentation where he described the details. And the main entity in the semantic DB is the notation. But I need to say that this is the old name for symbol information. why do I use denotation in my presentation? Because all the current code in the Scalafix repo uses only denotations. So it's like it's process to migrate to a new version in ScalaSphere, but now it's only denotations. Well, and denotations contain meta information about object, val, trait, class, definitions. Well, a lot of info. And how to access to the denotations? So we can access index of semantic DB by stx.index, and that index have a method called denotation that takes a subtree in our AST and returns optional denotation. Well, it's optional because not every subtree has some semantic information. Well, and now we are easily able to check that the trait, the parent of the some traits is sealed, whereby well, just one function is sealed. Okay, so again, putting all together, we have such example. I have just copied that is sealed function from the previous slide. And again, we have tree that collect, match only on definition of traits, retrieve the modifiers template, and then check that parents for the trait contains at least one sealed parent. And then we also check that the trait itself doesn't has the sealed modifier, and then we throw an error. We can't have final traits. It's only sealed traits. Yes, but if we with classes it would be final, of course. Okay, so that was the two simple examples how to write linting rules in the Scalafix with syntactical and semantic information. And let's move to rewriting. Consider the similar task is to add the final modifier to the case class. Again, we can look at the note of class definition, but it's very similar to trait definition, so I'll skip it. And well, again, we write analysis of the code. So tree.collect, then match only on defined class, retrieve the modifiers, and then check that modifiers indeed have a case modifier and doesn't have final modifier, and then do the actual rewriting by the add final method. I will give the definition for that method in the next slide. And the last important note here is spatch method. It just combines the sequence of small patches into the one, because we always need to return only one patch, not the sequence. Okay, and patches. So any code replacement in the Scalafix should be packed in the patch. So these modifications are done by adding regular plain strings to the tokens with such methods as stx.addLeft and addRight. So it just takes a token, takes a string, and adds a string to the left to the right. The stx has also some methods except this, but methods to work with that rewriting IP, but I will need only addLeft actually. And And the important thing here is to skip annotations, because we can't add final modifier to the annotation. It just won't compile. So yeah, we find the first not annotation modifier and add the string final with space to the left. We should always find that at least one modifier, because it's case class. So case is modifier, and we can always find that case thing. And well, so it's the branch with none is impossible. Okay, so that was another example, quite simple, of rewriting. And let's take a look at the built-in rules. What can we do well, in Scalafix already? We can block, well, we have quite generic disable rule that just, we have quite generic disable rule that just disables some specific symbols. We should specify the full qualified name of that symbol, and also can specify the message for the lint message, so it will be printed out when Scalafix will find that construction in our code. So in this example, we are blocking as instance of a symbol and option.get. Well, because we don't like exceptions, we don't like we like pattern matching, and well, these methods are quite bad for Scala. And disable rule has several modes. So first mode is if syntactic. If syntactic works only in the generator code. Well, in implicits, in type inference, for example. Here we block implicit conversion that converts any object to the string when we want add this object to some other string. Okay, and the next mode of disable is blocking by regexes. It's very helpful when we want to block everything in some package or some module. So here we are blocking all mutable collections in the Scala. So list buffer and mutable hash map will be blocked. Okay, the next mode is called unless inside. We want to block symbols only outside of some safe blocks. Well, here in my example, we have safe block try and symbol option.get. Option.get can produce an exception, but child block will catch it, and well, everything will be fine. So if we write option.get outside the try block, it will produce error. If it's written inside, it's okay. This rule, the main purpose of this rule is to enforce EO monads in your code. For example, if you have Scala Z or cats and want to use EO monads from these libraries, you can specify safe blocks as EO monads and specify symbols that uses some that which have side effects. So you can use side effects inside the EO monad, but outside it's blocked. Okay, and the next rule is disable syntax. Basically, it's just a big set of small syntactical rules. So we have here we can block keywords, var, null, return, throw, well, and others. We can block covariant types, covariant types, default args and methods, implicit objects, implicit conversions, final values, well, and other things. Well, yes, it's just a big set of small rules. And the rest of the Scalafix rules can be divided into three groups. First group is porting to dirty, so from Scala code to dirty. The second group is to fix compiler warnings. So we have here, well, Scalafix just reads the compiler warnings, the compiler output, and, well, for example, remove some unused imports, or remove some unused definitions, or rewrites after tupling, and etc. And it has other useful rewritings. Well, I won't go into details again, but because, well, you can always go to the docs, and, well, it's it's better to read the docs, not my presentation, for the tools. Okay, and a few words about word remover, another linting tool for Scala. It's an older project than the Scalafix. If we are comparing it to the Scalafix, word remover uses compiler IP, so it's much more powerful than the simpler Scala meta and semantic DB IPs. Well, and Scalafix, because of it, has some limitations. But, well, it's powerful, but it's harder to use. Okay, and word remover is more major project. Rules work reliably and have been tested for several years. And Scalafix is raw at the moment, but it's quickly growing, and now supports almost all word removal rules and possibilities. And another important note is that word remover runs on compile, and Scalafix runs after compilation. And I also have one smaller repo that contains the mapping from the word removal rules to the Scalafix ones. So just, well, we have, for example, one word removal rule, and in the repo I listed config lines that you should add to your config to enable that port of the word removal rule. Okay, and limitations Scalafix. So it's the same scheme from the start of the talk. We have static code analysis. So limitation of static code analysis is that semantic DB is now under the development. So IP is quite unstable. Everything is changing. You can't rely on it. So it's a limitation. But it's limitation, but it's also a possibility to create new rules, well, to improve the Scalafix. So also we have limitation linting, because it's quite too hard to work with types, inheritance, and hierarchies in the Scalafix. But with the new semantic DB version 3, which Olaf was talking about, it should be resolved. So with the new version of semantic DB, it's now much easier to work with these structures in connection between things. And limitation rewriting is just inconvenient to work with that low-level tokens IP. You know, it's quite hard to work with simple strings and tokens. It's quite bulky. Okay, but also now there is a lot of work is going on in the Scala Center to improve that IP and to add more high structures. So to work with ASTs but not with tokens. Okay, and now there will be some examples from my experience when I ran into the Z limitations. First example is about linting. So there have been attempts to create a rule that blocks a given method and all its overrides. In my example, I would like to block equals method, object.equals, and all the overrides. So it should block equals on erase and should block equals on case classes. Well, you know, case classes override the standard equals method. Well, but at that moment, SemanticDB couldn't reliably support that kind of operations. So these attempts weren't merged into the main repo. Okay, and limitation of rewriting. So there is a rule called no final val in the disable syntax that removes final from the final val. Why it does so? Well, you can go to that link, and it says that incremental compiler now has some issues with final vals and doesn't work properly in such situations. So we need to remove the final modificator, and first of all we should find it. Then we should take the tokens of that modifier, final modifier. Tokens is the list of tokens, of course. And we should remove that list and remove also trailing spaces of these tokens. Well, it's not a long fragment of the code, but well, it's quite long for such easy operation. Well, if we would work on the ISTs, it would like just one filter on our tree. But here we have like several lines of not so obvious code. Okay, and at the end, I will list the future plans for the Scalafix. So, well, Olaf had the talk before me about SemanticDB version 3. So it should improve the semantic information in the Scalafix. It will allow more cool rules to be implemented, and yeah, the annotations are now symbol informations. Yes, it will be more reliable. Well, it will contain more possibilities and just more stuff. And for the limitation of rewriting, we have Scala syntax. Well, Scala Center has Scala syntax repo. It's for replacement. It's a replacement of low-level token IP in rewriting. So basically, it's just a pretty printer of Scala meta AST, but it's not so simple. It should preserve the comments, the blank lines, blank spaces in the user code. So it's kind of tricky to do. And well, that's the end. And I'd like to finish my presentation with the Olaf quote. Well, nothing is going away. Only more features are getting added, and the functionality is becoming more robust. Well, that's all. You can ask questions now.
I have two related questions. One, how you deal with recursion. If my patch will introduce some changes that potentially should trigger other rules, can you deal with that? And second question, they're related. How you deal with conflict? Like if you have two rules and one will do rewrite one way, another will do conflicted rewrite another way. How you will resolve this?
Well, about recursion, well, it doesn't do something smart. It just it just does a patch and well, it just resolves the dependencies. And about about the two rules that that are concurrent is well. It's also Scalafix also does nothing about it, so the first, well, it's quite random, I think. Okay. Oh. Yes.
Hi, so you said Scalafix works after the compilation.
Yes.
Yeah, so suppose you wrote some custom fix rule which breaks your code, so it won't compile anymore after that. So if you don't commit your changes too often, if you spoil something, do you have some mechanism to prevent such changes which break your code?
Well, as you see, the patches are quite simple. So just like regular strings added to the tokens. Well, so there is no mechanism to prevent well, such complicated.
So maybe let me help you. So you said, for example, that if you have some annotations, you have to filter all these rules so that you don't modify them, because then something will break if you do that.
Here, yeah?
Also for,
well, yes, if I will add final, well, that string final with space to the annotation, that the result code won't compile. Well, yes, that's not.
After applying the rule, it does not check whether it compiles or parses afterwards. You just have to recompile in your build and find out and run the test
Yes.
suite. But if it breaks something, that's a bug in the rule that should be fixed with test cases, etc.
There was already mentioned recursive changes, and I would like to ask another question about recursion. Suppose we have some recursive context, for example, recursive anonymous functions, say DSL. We have such domain-specific language in a project that I'm working on. We have an anonymous function that return another anonymous function, another can return another anonymous function, and so on, so that you can have like a chain of these arrows. And we have had a problem with reformatting with Scala style, because after some version it just broke and it didn't format it well. And I would like to ask Is there a way to handle such recursive context
Well,
in Scalafix?
if you want to format the code, you should well, you should look at the Scalafit project, because it's not about formatting. Of what do you mean?
Okay, any more questions here? Okay, no. Thank you very much.